Hello everyone. Today I'll start the first session on IoT. I'll go to the agenda of the session. So let's start with agenda. First is background, why IoT is needed in real world scenario, why should one learn IoT, definition of IoT and its applications, architecture of IoT, use cases, challenges and future scope. I'll discuss one by one. But before going to background, can you tell me who is Kevin Aston? Kevin Aston is co-founder and executive director of the Auto ID Center at MIT. He first mentioned the Internet of Things in a presentation he made to Procter & Gamble in 1991. That means he has coined the term IoT first. That is inventor of IoT. Now I'll come to background, means I'll discuss some stories and some scenarios by which you can understand what is IoT. Look at some scenarios. Imagine a situation. You left for the office and left the tap on by mistake. It happens frequently with us. Your apartment owner calls you to complain about it. What you will do? Will come back from office or take a leave? Solution: remote water system control using IoT. One click and you switch off your tap water and apartment owner as well. Another one. Think of a day. You went out for a nice long vacation only to find out later that you left the rear door unlocked. It is a happy coincidence. There was no burglary. It happens with us frequently. What is the solution? Once again, IoT. Automated security and door control using IoT. Whether you click or not, you know your home is locked when you are out. It senses you and unlocks the door for you. When you leave, it automatically engages patrol mode. Another scenario, very interesting scenario. Think of a day. Your child has gone to school and the tension eats you up as to what they are doing. Solution: wearable GPS and health tracker using IoT. You can now track your kid anywhere through mobile app or website. On the other side, your kid kind of finds the device cool. Think of a week. Every day is hot and sweaty. You wish that the AC would automatically turn on an hour before you arrive. So you enter to a cool homely environment. What you will do? Solution: once again IoT. App-based smart application control over the internet. Either schedule or click to turn your AC on or off at the preferred times you want. Another scenario. Think of a condition where you are late to bus depot. You dearly wish the bus has not arrived yet, but you do not know. It happens with us frequently. Solution: app-based bus tracking using IoT, or it may be a transport management system app. We can now track the bus at real time and can determine whether or not we can catch it. No more running. So by these scenarios, you can understand what is the use of IoT and what is the IoT and why it is needed. Now I'll come to a story of a country called Estonia, which is very close to Russia. You can see from the map, but it is a very small country. I'll tell you the success and tragic story of Estonia. Declared independence in 1980, repeatedly occupied and contested by Nazi Germany and Soviet Union, 7.3% of the entire population killed during World War II. Independence restored in 20th August 1990. Just imagine, independence restored in 20th August 1991. Half the country did not had phone lines in 1991. That means developed country. So what is the success story? Ranked 30th in Human Development Index, most digitally advanced society now. Held election over internet in 2005. The first state to provide e-residency in 2014. So what is e-residency? That means if you are an investor, if you want to invest money in Estonia for doing business, so they will give the e-residency, online residency. Okay, I think Estonia is the first state which is providing this facility called e-residency. 97% of the schools were online by 1997. They got independence in 1991, and within a 6 year, all the schools were online. Imagine it. So I'll tell you the success story of Estonia one after another. 2000, cabinet went paperless. 2002, free Wi-Fi to everyone. 2007, e-voting. 2012, online tax returns. Now, chip pin identity card. I think in 2021, everything is online in Estonia. Now, there is a tagline. Norway had oils, Finland mobile phones, as you know, Nokia, Sweden with design. What does Estonia have? The major reason behind the success of e-Estonia is the use of IoT technologies for societal good. That means they have adopted IoT earlier than us, and that is why they are a digitally advanced country now. So now, why IoT is needed in real world scenario? The first one is that more data means what? The better decision. Obvious. As you know that from the IoT network, we are collecting huge amount of data by which we can take the correct decision. Number two, ability to track and monitor things. Already I have explained that we can monitor everything, your devices, that means it may be your home devices or it may be other one, by using IoT, app-based solution, right? So that means we can track your devices, that when your device is not working, when your device is not performing with correct efficiency and all, right? So number three, lighten the workload with automation. That means if everything is automated, if we are using home automation, right, what will happen? That you automatically switch on your AC, your microwave, your refrigerator, and all these things, right, remotely. So that means it's lighten the workload with automation. Increase efficiency by saving money and resources. Let's say I'll tell you one example. In case of home automation, when you are coming out from the room, if you are using the IoT app or let's say home automations, automatically fan, AC, and all lights are automatically turn off, right? So that means we are saving money also, right? Then better quality of life. That means obviously if we have automations, then always we have the better quality. That means you can control remotely everything, right? Already I've given an example of in summertime you want that whenever you enter into your room, the entire room is chill AC. So in that case, what will happen? You can, if you can remotely on the AC before we enter into this room, so we can get the, I mean, cool environment. So that is the, that actually give you the better quality of life. These are some reasons why IoT is needed in real world scenario. Okay. Why should one learn IoT? So I will read out some statistics by which students, researcher, professional can understand others that why IoT is needed, and why one should learn the IoT. Companies will invest up to $1.1 trillion in IoT by 2023. Every second, another 127 devices are connected to the internet. by 2023, 70% of automobiles will be connected to the internet. By 2024, the global IoT healthcare market is expected to reach $140 billion. There will be 41 billion IoT devices by 2027. Total economic impact of IoT could range between $4 and $11 trillion per year by 2025. Imagine. Over 60% of US cities are investing in smart city IoT technology. There will be 1.9 billion 5G cellular subscription by 2024. The home IoT market is expected to grow to $53.45 billion by 2022. Can you imagine it? The demand of IoT. Okay, and that is why one should learn IoT very well, because this demand will create a lot of job opportunities for researchers, students, professionals, and all. So that is why the people must have a deep understanding about this IoT. So now I'll come to the definition of IoT. What is IoT? What is Internet of Things? Internet of Things means internetworking of devices, that is the smart devices. The main purpose is to uh, collect the data, right? So I'll read out the definition now. The connecting everyday things embedded with software, electronics, and sensor to the internet, enabling them to collect and exchange data. The purpose is the data, right? A point to be noted, the things mean that I'm talking about the smart devices, which has electronics, software, and the sensors, and they can communicate each other for the purpose of collecting and exchanging data, right? So now you can ask one question to me: is it possible to form IoT network without internet? Yes, absolutely possible, because you can also connect devices by using Bluetooth also, right? But if you think the scalability of the IoT network, then internet is must. Without internet, you cannot store the data into the cloud. You cannot connect other devices also. Those are not in your place. Okay, so that is the main thing. So this is a very good picture to understand IoT, this Internet of Things. You can see a lot of smart devices over here are connected to form IoT network, like a laptop, tablet, smartwatch, phone, all the robot and all these things. Now, what are the things? Alexa, mobile phone, that is smartphones, smart car, smart home, smart bulb, smart locker, all are things. Others say smart things. So now I'll tell you how these things are connected. Right, that is the network infrastructure I'm talking about. So frequently used network infrastructures are cellular network, Wi-Fi network, Ethernet, Bluetooth, low power WAN, Zigbee, NFC, RFID, and etc. etc. But I can say the most popular is Wi-Fi network, right? And it is easy to use because most of the cases in our home, in current scenario, we have the Wi-Fi, so we can connect it through the Wi-Fi. So Wi-Fi is the first one, a popular one, rather say, or preferred one, we can say. Then you can use cellular network or GSM, or it may be a Ethernet. Okay. So some of the application of IoT you can see. This is starting from consumer to supply chain management. Okay, there are many applications like consumer and home, then smart healthcare, security and surveillance, healthcare also, then transportation, retail, industrial, and even in the space also people are using IoT. Already I have explained few. So now I'll come to the IoT system architectures. Point to be noted: if you want to build IoT network, so what should be the system architecture? There are four things you need. We have to have, right? First, the things that is smart things, that is the IoT devices, which is sensor, electronics, and software. Number two, the IoT gateway, through which uh, things can be connected to internet, right? That is the most important thing. That is switches and the routers, or wire or wireless. That is IoT gateway. Third is the network infrastructure. Already I have discussed, like Wi-Fi, cellular, and all these things. Then the cloud. The cloud is important because from the IoT network, lot of data are generating. So where you store this data? So that the cloud must be into the picture, right? So that is why the cloud is important to store, to analyze, to visualize the data of IoT network. Okay. So these are the four components are very important for any IoT infrastructure. So now I'll tell you the layer architectures of IoT one by one. Initially, IoT architecture started with three-layer architecture. If we go top-down approach, there is the application, network layer, and the perception layer, that is physical layer. If you go bottom-up approach, then you have the perception layer, that is physical layer, network layer, and the application layer. But the problem is that here they have not mentioned the storage, the cloud, as a special layer, or any machine learning algorithm. They have not used this. Or so after gathering of data, so how to filter this data, right? So these are not mentioned in this architecture. That is why we'll come to the next one, that is the four layer architecture, where people have introduced the cloud. The first one is the once again sensing layer, the sensor, the physical device. The next is the network layer. They are using wireless, TCP/IP, all these things. Third is the middle layer, where we have the cloud databases and all. And lastly, we have application layer. But the problem of this one is there is no user management over here, right? Or privacy. So that is why they have introduced another layer above the application layer, that is called the business layer, that will actually control the entire system. So that's why they have introduced a business layer. So the first layer is perception layer. Once again, sensors, physical devices are available, like Raspberry Pi, Node MC, and all these things. Next we have a network layer, where you have wire or wireless, or you can use the TCP/IP over here. Then the middleware, that means your cloud, right, or databases. And then you have an application layer, where you have an app, that is home automations and all. And then lastly you have a business layer, where from you can control the entire system and then also maintain the user privacy. Then security aspect came into the picture. That means you have to introduce the security, because already I told you the IoT network generates lot of data. So that is why they have introduced another layer, is called observer layer, and the security layer also. You can see from the picture. So first is the perception layer, where you have the different sensors and the devices. Then you have observation layer, or let's say observer layer, where the authentication is done. Third is the processing layer, where we process the data processing, right? Extract the user data, right? Remove the unwanted data. Then you have to impose the security, that means encryption, or let's say hash encryptions or decryptions, right, for securing the data. And next you send the data through network, where you use either wireless network or wired network. You can use TCP/IP also. And then you have the application layer over here, so like smart home and all these things. Okay, this is the all about the six layer architecture. Then after that we have proposed one other architecture, that is called the seven layer architecture, where you have the perception layer at the bottom. So where we have the sensors and all devices, physical devices. Then after that we have the data processing layer, where we have the cloud or databases. And then we have the network layer for transmitting data. Then you have a middle layer, so where we have the once again the cloud APIs and all. Then we have introduced another layer, is called the big data analytics over here, right, where you can use the machine learning over here, this layer. Then after that we have the application layer, but in between we have a gateway to connect this internet. Okay, so in application we have a smart home and all these things, and lastly we have a business layer. This is all about the 7-layer architecture. So this is the most popular currently. So people are also using machine learning or a lot of analysis on that IoT data. They also use EDA, the exploratory data analysis on the IoT data to visualization purpose, right? So the conclusion is that there are three types of architecture: the past, present, and the future. In past architecture, device can connect to cloud directly, right? The smart device I'm talking about. But the problem is this architecture is, so there's a delay. So if a device has requested for a data from the cloud, it will take some time to come. This is the first problem. The second problem is the security issue. Okay, so that is why another architecture came. So that is the basically the present IoT architecture. You can see between cloud and the devices, we have another layer that is called the fog layer. The fog is basically a node, the server, you can say. So first, device can connect to cloud for any query. Then, if cloud fails to do this thing, then it will connect to cloud through fog, right? So that is the main thing, and this is the recent architecture because that will reduce the delay as well as maintain the security also. So the third architecture we have is basically the any device can connect to anyone. So you can see from the picture is an entirely heterogeneous architecture. That means from the airplane you can control your refrigerator. Okay, that is the future IoT architecture. Okay. So that means we have first pass architecture where devices can connect cloud directly for any request or any sending data and all. Second is there is another layer between cloud and devices that is called the fog layer, and device also can connect each other. So first devices are connecting to the fog for data, and then if fog fails to do it, then it will connect to the cloud through fog. So that is the thing, and the third one is the heterogeneous one, that is any device can connect to any device. So now I'll come to the some use cases. The first use case is a smart city. So uses IoT to operate and manage operations on the city. Huge amount of data collected, that is basically the big data, as we know. Artificial intelligence and machine learning techniques use this data to provide various intelligence services. Okay, so that is the main thing. So I'll tell you now some of the components of smart city. You can see over here the smart water management, smart metering, then we have smart grid, smart transportation, disaster management, smart ICT, smart building. So there are many components, right? So you can take up each of the component as a single IoT project I can implement also. Then we have another use case, that is agriculture, because a lot of investment are actually coming up in agriculture, the smart agriculture, you can say, smart farming. Real-time monitoring and analysis, you can analysis the field condition. Okay. Then we have a predictive alarm, so we can give alarm to the farmers that this field has some problems and all. Livestock and crop monitoring, we can also monitor the crop by using IoT, especially software and platform for agri sectors. So please note it one thing that Microsoft India has developed one product for agriculture that is called Farm IoT. This is very useful product. People are using it, right, and getting a lot of benefits from this. The third one is the smart grids. As you know, that means whenever any power station is generating a power, they will not feed it to directly to customer, so they'll send it to the grid, and from the grid distribution and transmission and distribution will happen. So that is why you have to control the grid, that is the demand and the you have to balance the demand and the what I can say, the supply, the demand and supply. Okay, electronics power conditioning, efficient control of the production and distribution of electricity, Variety of operational and energy measures, uses of smart meters, smart appliances, and renewable energy. Because that another thing, you can manage the energy by different renewable energy sources. Okay, and there is another thing. Nowadays we are introducing a smart metering system. That means if we have the smart meter, they will actually measure the your energy consumption automatically, and then they'll send the bill, and you can say that how much we have consumed energy like this. So that also helps the smart grids. So that is another use case. So this is the some snapshot of any power distributions and transmission, right? So power generator, then transmission, then distribution, then it will go to the different types of customer. So the fourth one is the smart transport. Already I have discussed this thing, that is hassle-free journey, visibility on arrivals, departures, route information you can get from this, multimodal fare integration with variety of options, right? Intelligent and automated traffic management, that is another important thing for smart transport, because by which you can reduce the traffic jam. Okay, think many of you are using smart band, right? A smart watch, through which you can get to know that your health details, you can say, like a number of steps, and then water consumptions, then your BP, your heartbeat, and all these things. So that is another IoT use cases. And next one is the healthcare. That is, as you know, that healthcare is nowadays, having a lot of demand, the healthcare solution by using IoT. So that means generally in healthcare, what actually happens that, so they have the body area network. From this, lot of data are collected, and then you can do the lot of analysis on that. Okay. After that, we can send those data to patient parties or doctors or nurses. So, but people are using a band body area network for this. This is a smart ambulance. As soon as you receive any request, right, they will find a hospital where patient can be admitted, right? If his hospital is not available, then it will route it to another hospital. This is a smart ambulance facility. This is the disaster management system. Here I have just shown the only one, the fire case, the forest fire. So in this case, we have the sensors like CO2 emission sensors, right, and the temperature sensor. So that will sense the fire and immediately report to the station, and accordingly station will take the actions, and they store the data into the cloud with all the details, temperature and the carbon emission and etc. This is another use case. So now some challenges in IoT system and service design. The first system design issues are designing of low cost sensors. Okay, it's very difficult designing of low cost sensor or customized sensor, let us say. Customized IoT gateway design for specific application, that is another important issue. So how we can design the customized gateway for a specific application is very good, because we are sharing the gateway of different ISP internet service provider. Effective spectrum utilization for IoT front-end communication, that is another issue nowadays. A major challenge in today's IoT network. Application design issues. What are the application design issues? Where to store the data circulating within the network, that is another issue. So we are using cloud, different clouds, but who maintains the security? Who, how to maintain safe and storage of data, how to maintain continuity and integrity of data, that is another issue. So that's why we have to use a lot of security tools that are like blockchains and other, to maintain the integrity and the security of the data, how to eliminate the noise from the data. So trade-off between the design of fast and scalable mechanism versus data privacy. So we are actually working, this is some of the design issues are there. So now future scope, there are three things. Yes, most of the IoT device are low power device, because Raspberry Pi and all Arduinos, and then Node MCU, these devices are basically low power device. That means backup by battery, right? So that's why if you want to design some cryptographic algorithm for security and any other type of algorithms, so you have to design the algorithm in such a way that it should be energy efficient. Okay, that's the first issue. Then you have to maintain the security. Already I told you, I have to network generates a lot of data, That's why you have to secure the data using some recent technologies like blockchains and other one. And then real-time data, because IoT always need the real-time data, not the fabricated data or machine-generated data. So that is another important aspect. That means always you need the real-time data to analyze the data to get the correct result or to get the correct decision. Okay. So this is all about the session. Thank you very much.